This problem is similar to our last problem, with the exception of that we are looking for g prime of 2 and not g of 2. As I look at how the function is defined, g of x equals the integral of x from x to x squared of f of t dt, f prime of t dt. What I can take from that is that this would be f of x squared using the fundamental theorem of calculus minus f of x. If we knew what the antiderivative of f prime was, we would say it was f. Well, if we're going to take that and turn around and take the derivative, we get g prime of x would be the derivative of f of x squared would be f prime of x squared, and don't forget about the chain rule, we would multiply that by 2x, minus the derivative of f of x, which would be minus f prime of x. We didn't really have to go through this step right here if we know the second fundamental theorem of calculus, which would really just say, let's go and move straight to this. I find it helpful to build this, at least to understand where it comes from. That helps me execute much more effectively. Well, now we're looking for g prime of 2. That means I'm looking for f prime of 2 squared times 2x, or 2 times 2, minus f prime of 2. Well, f prime of 2 squared, let's see, that's 4, gives us a value of negative 2. So f prime of 2 squared is negative 2 times 2 times 2, or times 4, minus f prime of 2. And I'm looking for, here's a value of 2. The y value is 2 as well. And that means we've got f prime of 2 is 2. Negative 2 times 4 is negative 8. Negative 8 minus 2 gives us negative 10. Turns out to not be so difficult of a problem after all.